Okay, so the next thing that we're going to do for our applications is create a air photo interpretation map. And our main tasks for this video, we're going to be looking at how we interpret based on photos or imagery. We're going to be then creating our own air photo interpretation map. And finally, we're going to be looking at some real-world applications for this technology. Okay, so air photo interpretation is taking some kind of aerial photo. There's a really basic one right here. And in this case, we're going to be using satellite images and digitizing the features that we can see with our own eyes. So in this photo, we can see a road, or kind of two roads. We can see some trees. We have 4 fields. And the way I like to think about this is that if you were to take a translucent piece of tracing paper and place it over a photo and then start drawing features using our 3 vector geometries right on top of it. So for this example, I'd first draw lines representing the roads, and then I would draw 4 polygons, 1, 2, 3, and 4, representing the 4 different fields. So you'll notice this is very similar to the way we first learned to digitize features with our baby landscape and when we were making that reference map of the campus, except this time we're not using a base map, which is a bit neater, but we are going to be using photos. And as we'll see, things get a little complicated when we start using actual images and not a nice, neat base map to create geometries. Okay, so let's get started. I have done a little bit of work already. So I created a new map. You're going to be working on most of this map by yourself as well. So I'd like you to name it with your last name and then air photo and submit it in the share folder once you're done. And I've also found Sunridge Orchards in North Bigham Street, Middlebury, Vermont. It's actually in Cornwall, just outside of Middlebury. And this is a big orchard just down the road from us. And let's keep zooming in. So here's the property. And the idea for this project is that a Middlebury student a couple of years ago created this map of the property and digitized all of the fields contained in it and named them, as you can see, and put an acreage on each of them. And they did this using a software called ArcGIS, and then they had to bring the map that they created there into Adobe Illustrator to do it. And it took a really long time and was very complicated and messy, but I want to show us how we can create this same map and create what I would think is perhaps even a better map using Google. And we're going to do it in far less time. We're going to use only the technical expertise that we've already gained. We're going to make this map more attractive, and we're going to make it far easier for the user to enter in more attribute data really easily if they ever wanted to. So back to our new map. First thing that you notice is that we've got these kind of funny light pixels, it looks like. It's kind of hard to tell what this is. So the first thing to note about air photo imagery is that it is not always neat and nice. So it looks like this part of the map was probably covered up by clouds or something else when they did the original photo, so they had to go in, and you can kind of see here this little outline, and re-pixel in some other photos that had a better quality, but we're going to work around them. It's not going to affect how we digitize too much. So I'm going to digitize one field with you, and then I'm going to have you guys do the rest on your own. I'm going to get rid of my search icon since I'm not interested in points for this map. Now I could digitize more features. I could digitize the roads, I could digitize the ponds over here, the buildings, but right now I'm only interested in replicating this map. So I'm only going to use polygons, and I am only going to digitize the fields. So I'm going to digitize this field, which is called what is it called? Quonset field. So I'm going to hit draw a line, and I'm going to go in and kind of do this rough. If you look at the PDF, you can see that they've used more than one polygon to represent each field. The person who did it was really careful, and I'm not going to be quite so careful. One polygon per field is fine. So I'm going to keep going. You guys can do this a little bit more carefully if you'd like. It helps if you zoom in a little bit. But here's my first polygon, and I am going to name it Quonset, which was the name of my field. And then I'm going to create a new, so what I did over here, I'm going to hit save. So for those of you who have Pro, I'd like you to create a new field for each of your features, which is going to tell you the acreage of each field. So you can see it already automatically measured it for me. It's 28.7 acres. So what I do to enter in that data, I'm going to actually go over to the data tab over here. And I've already created this new field, but for those of you who didn't have it, you could click on one of these little icons and say insert in column before or insert column after. And then I'm going to double click in the cell and I'm going to put in that value. So I'm going to put in 28.7 it was. And it should work just like that. Great. And now I should be able to click on my feature and you say I get that value right here automatically. Great. So I'm going to ask you guys to do that for the other 17 fields. So you'll have a total of 18. And that will be used as your assessment for this video. So how do you think the map that we've created, you can look at this map over here too, how do you think this would be useful and to whom would it be useful? So I don't think this map is probably all that interesting to someone who just wants to come and visit the orchard or is looking on their website, but I think it's very useful for the Hodges who own the orchard because they can go in and the same way that we added an acreage attribute, they can add a lot of useful attribute data for each field about things like crop yields, pests, irrigation, numbers, all sorts of stuff. And they can share it and update it automatically without having to invest a lot of money in fancy equipment or learn any more spatial skills than we've learned in these quick little videos, which is pretty cool. So another application of air photo interpretation, which uses a very similar technique but is in a different software, involves a project that I did last weekend with a software called OpenStreetMap over here. I don't know if you've heard of it. And we did this up at the Burlington Crisis Center in Burlington, Vermont. So in the wake of Typhoon Haiyan in the Philippines, geographers and geospatial professionals from around the country have been working in the OSM Task Manager and remotely mapping the areas worst affected by the storm using air photo interpretation. So what we did, I'm going to go over to OpenStreetMap, is we took photos from before and after the storm hit. So this is a photo of before the storm hit. And we compared the two of them in order to figure out which features, so mostly we were looking at man-made features such as buildings, roads, any kind of transportation structure, residential areas, how they were affected by the storm. And the reason why we do this is because we can take a look by comparing these two layers at the areas which need the most help and fairly distribute aid. So I'm going to look, I'm trying to find where someone had done some digitizing so you can take a look. Let's go in. So you can see here they've digitized a river. Here they've digitized some roads. There are some buildings over here. And they've just used our same basic geometries, and you don't really need any more training than what we've already learned. So pretty cool. So if anyone ever asks you why you'd ever want to learn geography or why it's useful, you can tell them we are a pretty useful, helpful bunch sometimes.